Hello and welcome back. In this lesson what we're going to do is we're going to dive deeper into what an instruction really is and how the computer sees it and how people see it. In the last lesson we learned about how instructions are just simple operations that the computer can do, and the result of those instructions is stored in the memory. So executed by the processor, stored in the memory. But we don't really know what these instructions look like, and we're going to find this out in this lecture. Before we go into what instructions actually are, you need to understand how information is stored within a computer. In the description below, I've posted 2 videos that explain how information is represented within a computer with ones and zeros. If you already know that, if you know the binary number system and stuff, you don't need to watch those, but if you don't, I highly recommend you do, because otherwise what I'm saying won't really make sense. So from now on, I'm going to assume you've watched those videos, or you know what binary is, and you also know that information within a computer is represented as a sequence of ones and zeros, and instructions are just another type of information within a computer, so they too are just combinations of ones and zeros that the designer of the processor deems appropriate to interpret as instructions. But who decides, or how do we even decide what the ones and zeros will be like? And in order to, and I'm going to walk you through that process by designing a small computer, a very simple computer that accomplishes the task we had in the last lesson. If you remember, we multiplied the number 35 by the number 47, and we broke this down into its simple operations of multiplication and addition and storing numbers in order to get the answer. And I said that this was basically a computer program, but I didn't really say how. And now we're going to find out how it could work as an example. So let's go back to the basic operations that we needed to do in order to evaluate this. We needed addition, we needed multiplication, which I'll represent as mul, and we needed a way to store store answers or to store numbers somewhere in the memory, and I'm going to call that instruction move. So our computer here is going to have 3 instructions: add, multiply, and move. What we also need to define is what the memory of our computer looks like. If you remember the model of the computer that I described in the last lesson, we have the processor, and this is the mathy part. This is the thing that does the actual computation, and it stores this result in memory. But what does this memory look like? Well, for this example, what we're going to do is we're just going to imagine the memory as 4 different slots. So we have 4 distinct places that we could put the memory into. You can think about it as, say, like 4 erasable whiteboard spaces. Only one answer can live in one of these slots at a time, but you can change that throughout the course of your program. So let's label these slots. Let's call this slot 0. This is slot 1. This is slot 2, and this is slot 3. So our program at any time can store numbers into slot 0, slot 1, slot 2, or slot 3. And if it doesn't make sense right now, that's okay. It's going to make sense a little bit more when we actually start making the instructions. Now, assuming you watched the video on representing information within computers, you know that computers don't really like words very much. They like numbers. And in order for us to represent anything within a computer, we need a mapping, or the official term is called an encoding. We need an encoding such from like the human world, where we understand addition, multiplication, to the 1101111 world of computers, right? So such that computers can understand what we're actually doing, right? And the simplest encoding that we could do in this case is to just number them off. So we have 3 instructions, right? I guess I don't need to rewrite them here. We have 3 instructions, so let's number them off. let's call add instruction 0, multiply instruction 1, and move instruction 2. And now, in order to turn this into ones and zeros, all we have to do is convert it to binary. So add will become, let's use a different color for this. Add will become 0, 0, that's instruction 0. Multiply becomes instruction 1, 0, 1. And move becomes instruction 2, which is 1, 0. So now we have the encoding of instructions within our simple computer. But this doesn't really, but this isn't the full picture here, right? Because if you remember in the last lecture, I defined an instruction as something with a well-defined input, a well-defined process, which we already have, so this is either add, multiply, or move, and a well-defined output. And the output and input here are still missing from my encoding. If I tell the computer to add, it needs to know what to add. And this is where these guys come in. So the computer needs some place to get information from to then perform any sort of operations. And let's start with the simplest operation here, which is actually the move operation. Let me switch back to yellow real quick. So here we have the move operation, and what the move operation is going to do is a very, very simple thing. It's going to take a value, v, and v can be any number, and it's going to put it into one of the slots, into either slot 0 up to slot 3. So this is all the instruction is going to do. And if we write this out, as an example of the move instruction, let's say move 3 into S0. So actually, let me write this in a different color. We're going to move the number, we're going to move the number 3, right? And that's just a regular number, into S0, right? And all that means is after the processor executes this instruction, the value within S0 is going to be 3, right? And this is all this does. So we can move, for example, 4 into S1, all right? And now S1 will have 4. So this is what our move instruction looks like. But again, as we said before, right? Computers wouldn't really understand 3, S underscore 0, right? It's not. It doesn't make sense. It needs numbers. It needs a ones and zeros representation of whatever this is. Now we have the first part here, which is move, right? Let me change colors again. So we have the first part here, which is move. So we know that I'm going to move this over here. We know what the first part of the instruction is. The first part of the instruction is 1, 0, right? Because in our instruction encoding, 1, 0 means the move instruction. Then we need a number to represent what value we're going to move, and then afterwards we need to represent the where we're going to move it. So since we're moving just regular, regular values, just regular numbers in here, we don't have to make an encoding because it's just a regular binary encoding. So let's say, so the number 3 is just 0, 0, 1, 1 in binary, right? That's the binary encoding of the number 3. So 3 in base 10 is equal to 0, 0, 1, 1 in base 2. So that's all that means. And then finally, we need to encode these slots. We need to know, we need to tell the computer which, we need to tell the processor which slot to store this value in. And as you can see here, we've already numbered them off. So we have S0, S1, S2, S3, and we can create a very similar mapping that we did to the instructions to the slots that we have. So S1, S0 is just going to be 0, 0. Oops. S1 is going to be 0, 1. S2 is going to be 1, 0. And S3 means 1, 1. So the last 2 bits of our instruction is going to be what slot we put the value in. So here we're moving it into S0, so the last 2 bits are going to be the number, or I guess the index of the slot. So now let's try this example. You guys can maybe try this by yourself. So try and put this instruction into ones and zeros, just like I did up here. I'll give you a second. Pause the video and try to do it. Okay, now that you're back, hopefully you figured out. So the instruction is still the move instruction. So 1, 0, right? The value that we're moving in is now 4, which is 0, 1, 0, 0. And the register, or the slot that we're moving the value into, is slot 1, which means 0, 1. So this is the instruction. This is the value V. And then this is the slot number. Okay, so now we have, just with this instruction, we have a computer that can store values. But that's not very interesting, right? We want our computers to do more than store values. We want to multiply this number.